So three-dimensional close packing arrangement. Suppose this is the first row of art spheres, this one is the second row, and we are placing the second row over the first row. This is the third row, and consider that this first, second and third row constitutes one layer. So we know we have built a monolayer lattice. Now if we want to place the second layer, we can place it in two ways. In the first category, suppose we place the green layers just above the blue layers, and again we put one brown layer just above the green layer. So this will be the type of arrangement. If we look it, if we want to look it from another side, this will look like this: the three-dimensional structure, three-dimensional lattice structure, and all the layers are identical. So we can say this is actually AAA type arrangement. And unit cell, if you want to look at one unit cell, in this case unit cell will be simple cubic unit cell lattice, because we see here this sphere, this one and this one, and consider this one, this one, this one and that one. So these 8 spheres forms what is called a simple cubic unit cell lattice. So this is all about the first category of arrangement. And we can also place the second layer on the groups of the first layer. How? Suppose this is the first row and this is the second row. We are placing the second row on the groups of the first row, and again we are placing the third row on the groups of the second row. These are the groups: this one, that one, that one. These empty spaces are groups, actually depressions. This forms one layer, so monolayer structure. Now if we want to put another layer, the green layer, you see, we can put the second layer on the groups just like the rows. And if we do this, we get two types of empty spaces inside these two layered structures. One is this blue empty space. You see the blue empty space? These are actually tetrahedral voids, tetrahedral empty space. And another one, these white spaces. These white spaces are actually octahedral holes or octahedral voids. We can say we can designate those empty spaces as voids or holes. So these are these blue regions are tetrahedral holes, and these white regions are octahedral holes. Now if we want to place the third layer, the first row, the second row, if we want to place the second row on the groups of the first row, and now we want to put the third layer, we have completed two layers already. Now we want to place the third layer over the tetrahedral holes. Where are the tetrahedral holes? These blue spaces are the tetrahedral holes, actually. Now if you want to place the third layer on the tetrahedral hole, it will be like this. You see, the third layer covers all the blue empty spaces. Only the white empty spaces are left now. This one, etc. Once again we see that if we join the centers of these spheres, we get a hexagon. And for the second green layer, you remember the second layer were green balls. If we join the centers of the second layer spheres, we get triangle. Once again, if we want to see this structure from the other side, it will be like this. This is the first layer, this one is the second layer, and that one is the third layer. You see, third and second layer are alike. Third and first layer are almost same, in the same position. This sphere and that sphere are in the same are on the same line. This sphere and that sphere are on the same line, but these yellow spheres are staggered with respect to these blue spheres. Now, what will be the coordination number of a particular sphere? Say this sphere. The coordination number of this sphere will be 6 in the plane. You see, 1, 2, 3, 4, 5, 6. So 6 immediate neighbors surrounds this yellow sphere, and above the yellow sphere, a yellow layer, we see this in this blue layer there are 3, 1, 2, 3. There are 3 immediate neighbors, and in this case we see 3 immediate neighbors. So 3 above, 3 below, and 6 in the plane. And now we got the coordination number of hexagonal close packing. Hexagonal because the unit cell will look like a hexagon here. So coordination number will be 3 above, 3 below, and 6 in the plane, total 12. And unit cell is actually hexagonal prismatic. That is why this type of close packing where the third layer is kept over the second groups of the second layer, actually over the tetrahedral holes created by the second layer, are hexagonal close packing. We see this is if this layer is A type layer, and if this layer is A type layer also, this is B type layer. So actually this is AB type of arrangement, AB type of arrangement. If this we want to see the congested model here, the solid packed model here, close packed model, so this will be like this. This one is the hexagon, suppose this one is one triangle, that one is another hexagon. Now, so this is another triangle, and this one actually represents the hexagonal prismatic structure. Now the total number of particles per hexagonal unit cell. Suppose this one, the hexagonal unit cell, suppose this sphere, consider this sphere. This sphere